Hello and welcome to today's European SharePoint Office 365 and Azure Community webinar. My name is Shane and I'm delighted to be joined by Jaap, MVP Rubrik, the Netherlands, who will be talking to you today about manage your Azure infrastructure as code with Terraform. Remember to join the conversation about today's webinar on Twitter. Our Twitter handle is @EuropeanSP and our hashtag is ESPC20. Don't forget to check out the Resource Center. This is updated daily with the latest blogs, ebooks, webinars, and how-to videos. Simply visit sharepointeurope.com and click the content link at the top. This week, 25th to 29th of May 2020, all week, join us for free Azure Learning online from Microsoft, MVPs, and industry experts. See sharepointeurope.com for further details. After the webinar, we will have a questions and answers session. Type any questions you have for Jaap into the questions window. Questions will be selected and answered at the end of the presentation. This webinar will be recorded and added to the Resource Center where you'll be notified by email when it is available. And now I'm going to pass you over to our webinar presenter, Jaap. Hello, Jaap.
Hello, and thank you for the introduction. Can you see my screen okay?
Is everything I can indeed. Yeah, that's super. Take it away.
Excellent. Thank you very much. Welcome, everyone, and I hope you're all interested and excited to hear about managing your Azure infrastructure with Terraform. So I'd like to start out with this quote. Those that don't automate are doomed to repeat themselves. In my journey as an IT engineer, I've definitely repeated myself more than once. And this quote was actually I actually took from one of the PowerShell wallpapers, and it's a bit of a segue in how I got started with automation and with infrastructure as code, and just my journey myself as an IT professional. So a little bit about me. First of all, looking at the picture, you can definitely see that my hairstyle has changed a bit since that picture was taken. Fortunately, I haven't been able to get a haircut lately because of circumstances that I'm sure everyone is aware of. Yeah, I'm a developer advocate at Rubrik. What that means is I get to write and talk about a lot of cool code. Do a bit of blogging, speaking, and my interest is mainly in cloud automation, so scripting, infra as code, Azure DevOps, and security. And as part of that, I'm also a Microsoft MVP, Azure MVP. So what we'll be covering today, I got a bit of content for everyone. So what we'll start out with is Terraform. What is Terraform? How does it actually work? So we'll get a bit into the internals. Then we'll move over to working with Terraform on Azure. We'll be doing that through Azure CloudShell. So I'll give a bit of information about what CloudShell is, how we can use it, and then we'll head over to a demo, and I'll show how we can actually start deploying resources on Azure. After that, I'll summarize everything, give a bit of a takeaway, and then we'll have some time for Q&A. One of the things I like to do, because we're not able to do this as an in-person event, so if you have any questions, it doesn't really matter how basic the questions are. It's just nice to have a bit of discussion. So if you have anything coming up during the session that you think, oh, what did he mean with that? Just put it in the question box, and Shane will list those out at the end of the session. Cool. And with that out of the way, let's talk about Terraform. So first of all, Terraform is a product created by HashiCorp. HashiCorp makes a lot of cool products, and the one we'll be covering today is just going to be Terraform. So a fun fact about Terraform is actually the origin story of how Terraform came to be. Is that there was a new hire at HashiCorp, and at HashiCorp they have a work at home unless you have a very good reason to be in the office policy at the time. So the hiring manager told this developer, well, if you want to sit in the office, you better have a good reason. So this developer came in, and on a weekend he put together the Terraform project, and this actually became one of HashiCorp's main products. So what is Terraform, and what is infrastructure as code? Well, infrastructure as code is the concept of instead of manually installing and configuring and going to the works to get your application up and running, is to define this as code. So there's multiple tools to do this. If we're working on Azure, for example, we can use ARM, and we can use ARM templates to deploy resources both in Azure but also in Azure Stack. But what Terraform offers is it offers a product that can be used against different platforms as well. So it's not just limited to deploying resources in Azure, but when you're using other cloud providers, for example, you can connect to those. You can have the same kind of configuration language, and you can use this to start deploying, managing, and keeping your resources in the cloud up to date and configured exactly the way you want them to be configured. So that also brings us to the why we would want to do this. Well, I personally like to make my job easier. So whenever I'm managing any kind of infrastructure, I don't want to be the person that has to RDP into a server to see if everything is still up to date, or if anything broke and there's no backups and I need to completely redeploy a system. I don't want to do that by hand. So the end goal is to just have everything defined in code, and the moment something breaks, we can just take it away, redeploy it, and make sure that whatever data source we had for the resource gets reconnected to whatever resource we had. So the why, in the end, it's all about making our lives easier. So a little bit about Terraform. So it's I already mentioned that it's multi-platform. It's written in Golang. So Golang is a Google programming language. So anything that is used in Terraform, so specifically the Terraform providers, they are written in Golang. It's has two different versions. So we have the open source version. That's the version I'll also be using in my demos. The open source version is free to use, and there's also the enterprise version, and then you get it as a SaaS platform. We work with configuration files. So obviously the configuration files need to have a certain format, but at Terraform we're using the HCL format. So an important concept of infrastructure as code is that code is that there's two different ways of defining your code. So you can either do it declarative, or you can do it imperative. So in the case of a declarative style, you just define what kind of end state you need. So what this looks like and what a kind of configuration file looks like. So we can see here is that if we want to deploy 5 machines, in this case, this screenshot was taken from AWS. So we want to instantiate, we want to ensure that there's going to be 5 EC2 instances with this configuration. And what count 5 means here is we want to get into a situation where we have 5 resources. So if we would run this configuration for the first time, it will create 5 instances, just as we requested. If we run it a second time, it will inform us that it will take no action because there's already 5 there. If for some reason one of the resources was deleted just manually by an administrator, then by running it again, we would get back to the end state of having 5 resources. And with that, we'll go over to some of the use cases and the problems that we can solve. So, because Terraform can be used on multiple cloud platforms, we can. Well, some people like to say that you can just reuse your configurations on different platforms, and I guess it's true in the sense that you can use the same kind of configuration files, but because of the intricacies and the architecture of different cloud platforms, it isn't that you can just take your Azure template and deploy it onto AWS. Because in the way Terraform interacts with all these platforms is by using Terraform providers, and those providers they have their own configuration settings, their own resources, and the resources are of course going to be different depending if you're deploying on Azure or if you're deploying on other cloud platforms. But it does provide the common language, and the common language makes it easier to be able to reuse it for your entire infrastructure. And the way this is done is by using these different providers, and there's actually a lot of third-party providers, available in the Terraform repository. This is also one of the things that I do in my day job. I also manage and write the code for our Rubrik Terraform provider. And it enables you to get consistent deployments between different clouds, but also on premises. And the nice part of this is we can get a safe way to provision resources, because if everyone is just manually deploying resources, then what you'll end up getting is just a big resource sprawl in your environment, and there's going to be there's not a clear overview anymore of what is actually running in the cloud and what should be there and what is there. And one of my favorite use cases is it becomes extremely easy to create disposable environments. So if I want to spin up an entire lab environment, I can just have one or a couple of Terraform configuration files. I tell Terraform to take this configuration and apply this. Applies also the Terraform concept. Apply this to my production environment. But if I change a variable in there, it can also be my development environment. And by doing so, you can have an exact reproduction of your different environments. And that's just a fun way of deploying things. So if we talk about the Terraform CLI, so the open source, the free version, it comes with a single executable. Executable is called Terraform. If we're using it on Windows, it's terraform.exe. If we're using it on any other platform, it's just Terraform. There's a number of files that we work with when we're working with Terraform. The most important one, the only one that we're actually actually going to edit, we can make changes to, is the configuration files. But another important file is actually the state file. And what the state file does, it keeps track of what Terraform has done. So Terraform internally checks its state file and retrieves what has already been deployed, and it uses that as a source of truth. So there's also a warning there. Do not manually edit your state file for whatever reason, because you might end up in a situation where you don't want to be. Because Terraform is open source, it's extensible. There's a lot of plugins or providers, as they're called, in Terraform. There's basically two kinds of providers. You either have the certified providers, so they are certified by HashiCorp, and they're also in the HashiCorp GitHub repository. Or you can just create your own plugins, and all you need to do is have it up on GitHub, and then you can just link to it from your configuration files. So it's very easy to extend Terraform to manage any kind of infrastructure that you want to. But for most of the cloud or hardware platforms, the providers have already been created either by the larger community or by the third-party vendors that created it for their own products. So let's talk a bit about the Terraform workflow. So how are we going to get started with Terraform? So I already mentioned, if we want to do anything with Terraform, we have to call Terraform. So in this case, the Terraform command line. So we do Terraform init. So this is short for initialize. And what this will do is it will take a look at the configuration files. It will take a look at what kind of providers are in those configuration files, and it will make sure that those providers are available to Terraform. So if for example, this is going to be the first time you're going to deploy something against Azure, then it will make sure that these providers are available locally. The next step is Terraform plan. What Terraform plan does is it will take a look at your configuration, it will validate your configuration, and it will tell you what kind of changes it will be making. So in the example I gave earlier, where we have a configuration and we want to ensure that we have 5 virtual machines, if we do a Terraform plan, and there's currently 3 machines out there, if we run Terraform plan, what we'll see is, okay, what will happen now is 2 resources will be deployed if we would apply this plan. So that brings us to the next step. This is Terraform apply. So if we run Terraform apply, it pretty much does everything that happens with Terraform plan. And then at the end, it will ask us, do we actually want to apply these changes? Do we want to deploy the resources? And then the most fun or the least fun, depending which side of the fence you're on, is Terraform destroy. And we can use Terraform destroy to remove all the resources that we've deployed using Terraform apply. So as you can see, I left some white space in between. There are of course many more Terraform commands available, but these are the four that you definitely need. 2 of the other ones that are quite useful is Terraform validate. So validate if your configuration file is going to be functional. So this is different from Terraform plan in the sense that it will not validate your values if your values are as expected, but it will validate if your configuration file is correct. And then the last one is Terraform FMT. This stands for format. So this can make sure that your configuration files are formatted correctly. And the kind of formatting that is meant here, there's different ways of writing the configuration files, and by running format, you'll just have you use the HashiCorp preferred ways of formatting. So especially useful when you get when you get Terraform configuration files from different sources, you can ensure that there's consistent formatting and it's using the best practices. So I've talked a bit about the providers, but here's a screen cap from GitHub to give you an idea of what is out there, which ones are the most popular providers. So you can see that we have the Azure RM provider. So this is for Azure, and that's what we'll be working with today. There's also Kubernetes, Google, AWS, vSphere if you want to run your resources on premises. And we can see that all these providers are written in Golang. It doesn't matter if you don't know Golang, because if you want to work with Terraform, if you're an end user, you don't actually have to do anything in Golang. The only thing you'll have to work with is the configuration files. For the demo, I'll be using Azure CloudShell. And before I get started, I'll just give a little bit of explanation about what Azure CloudShell is and what my reasoning is why I'm using Azure CloudShell for this. So Azure CloudShell is a shell in the cloud, obviously. So it runs in Azure. The nice thing is it doesn't cost us anything. The only thing we need for CloudShell is we need a 5 gig image to be stored in our storage account, and we need to be a little bit used to using shells. So there's 2 different shells we can use in Azure CloudShell. We can either use Bash or we can use PowerShell, and both of these shells are running in Linux containers. So there's no there used to be a Windows version of Azure CloudShell, but that one's been decommissioned a couple of years ago. Quick overview. I won't go into into the details too much, but everything in Azure CloudShell runs on top of Kubernetes. The big takeaway from this is there's a lot of active containers that are ready to pick up the workload. So the moment you want to connect to your CloudShell console, you just get an active container, and it will get connected to your personal storage, and from that moment on, you're good to go. There's a lot of language support, and this is also the power of using CloudShell, because all the different languages are already in here. So we have .NET Core, we have the latest versions of PowerShell, Python, Node.js, Golang. So you can hit the ground running, and this is particularly useful for people that work in scripting or development environments, because you cannot always ensure that the tool that you want to use is going to be available if you're working at a client side, or if you're asked to do something and you can't work on your own system. By using CloudShell, you get access to all the tools that are installed here. You can install your own tools on top of this. These are just the languages. The other thing we have in CloudShell is we have a lot of tools installed by default. So we'll have Azure CLI available. If we're using PowerShell, we have a number of PowerShell modules to manage your Azure environment. But in particular, what we're interested in today is the fact that we also have Terraform available here. And the advantage of using CloudShell is normally you have to take care of secrets management. You have to provide your subscription ID, client ID. You have to have secrets, and you have to have a proper way of storing and securing this. But if we're using Azure CloudShell, we abstract this away, because the moment we connect to CloudShell, we're already authenticated against Azure. So the part of secrets management is already taken away. So that makes it a good starting point if you want to get started with Terraform without the fear of accidentally exposing your secret. because your secret in this case would be your would be similar to your password. And the thing that happens quite often is that you're working with Terraform, you're putting together some nice configuration files. You of course want to put this in source control because we're doing infrastructure as code. So we want to make sure that this is going to be stored and we can track the changes that are made. So we put it in source control, we put it in Git, and we push it up to GitHub. And then we find out that by pushing it up to GitHub, we accidentally put our client secret there, which means that everyone can now authenticate and deploy resources in your Azure environment. And that can potentially be quite expensive. And the challenge there is that by having these credentials exposed, some malicious people might want to use your Azure environment for their own personal gain. So it's a bad idea in general, both from a security point of view as from an economical point of view, because there's no stopping anyone to deploy 100 very, very expensive VMs to do some cryptocurrency mining or whatever else they'd like to do there. And with that, we're going to switch over to the demo. Let's see. So I'm currently in the Azure. Portal. So you can see here we have one virtual machine in our environment, and this is actually one of the things that if you're working with CloudShell, you'll run into this one with quite frequently, because the idea of CloudShell is it doesn't matter how much you use it, but it's meant for interactive use. So the moment you're connected to CloudShell, you have an open WebSocket connection. So you have an open connection that will take in these commands. But if you've been idle for anywhere in between 10 or 30 minutes, you'll get this timeout message. It says 20 minutes, but sometimes it's a bit sooner. And that might also be because there might have been a disruption in your connectivity. So the first thing we'll do is we'll reconnect to the CloudShell. You can see over here that I have PowerShell selected. And we're already authenticated against Azure. So one of the features is that we have a cloud drive, and your cloud drive is just an Azure storage account, so you can access this from any way. And if we take a look at what we have in here, you can see we have linux.tf. We have the Terraform.tf state. So I mentioned before, Terraform tracks its state by creating state files. And what we'll go into is we'll go and take a look into this configuration file, and it will automatically bring us to one of the features of CloudShell is that we actually have a VS Code web version available here. So what I can do is I can just type code dot, so that will open, if you would run this on your local system, this would open VS Code on your in the current path. And it does the same when we do this in Azure CloudShell. So we can see here we have a .terraform folder, Cloud Console, but also linux.tf. So we'll go into this file and we'll go take a look at what kind of resources we have defined here. So we can see that I want to create a resource group. I want to create a virtual network. My virtual network needs a subnet. We need an IP address. We need to have a way of accessing our network. So what kind of security rules are we going to put on there? Configuration for the interface, and then all the way down, we also specify which SSH key we're using. So because this is a Linux VM, so we want to be able to authenticate against it without a username and password. And the way we do this is by using a key pair, a public key and private key. So having this configuration, let's see what we can do with this when we're using PowerShell, when we're using Terraform, in this case in PowerShell. So I'll clear out the console. So the first thing I'll do is I'll run Terraform init to ensure that all the resources, all the providers that we need are going to be there. So we can see it's now initializing the provider plugins. If this would in fact be the first time I run this, or it's a system that has never done anything with Azure VM, it will reach out to the GitHub repository and will pull these providers in. So then the next step was, okay, let's run Terraform plan. Let's see what kind of changes will be made here. So we run the plan. It will take a couple of seconds because it will analyze what we actually have in Azure, but it will also check what is in the configuration file. So that's what's happening in the background now. And at the end of this, we'll get a list of all the changes that are going to be made. So the way that is indicated, we can see the plus here, and the plus indicates that it's going to be a new resource. And if it's a minus there, it will mean something will be removed. So when will something be removed? Well, if, for example, I'll just go back to the initial example I gave. We want to have an end state of 5 virtual machines. If we, for some reason, have 7 of those, if we would run Terraform plan against that, it will say, okay, we have 7 now, our end state is 5, so we'll remove 2 of those resources. So another thing we can see here, we get a warning. So we can see that one of the things that we're using, so address prefix, is in fact deprecated, and we should use the address prefixes instead. So this is where CloudShell is quite useful, because we can just run code again, we can take a look at our configuration file, and we can look for address prefix, which I already put there. And the suggestion is, okay, we should use address prefixes. So put the ES back there. And I happen to know that the way this is formatted is also different than address prefix used to be. So in this case, we just have a single string here, but we need it to be an array of strings. And the way we define that is by putting the brackets around it. So we still have the same value, but we're using the new definition. So I'll press save. I'll quit out of here. Clear my screen. I'll run Terraform plan again. And while this is going on, our warning should be gone now. And because the warning is no longer there, I feel secure enough that this is going to work as intended, and we'll be able to deploy our resources right. So deploying a resource with Terraform was Terraform apply. And it will now come with exactly the same information that we got with Terraform plan. The big difference is going to be that we'll get an option to actually apply this. So here it asks us, do we really want to perform these actions? And in this case, we will say yes. It's of course also possible to auto approve or to force Terraform to just run, because you don't always want this to be interactive. Actually, in most cases, you wouldn't want this to be interactive, but for demo purposes or when you are using it interactively, I would never advise you to run -force, because if for some reason there's something unexpected in your configuration files, you might end up deleting more than you intended or spinning up a lot more resources than you thought you would. So I press yes here. So this will take a little bit of time, but what we expect to happen is, and this is why I'm doing this from the Azure portal, is we would expect a virtual machine to start showing up here. And this will take a little bit of time. So while this is deploying, what I'll do is I'll show another feature of Azure CloudShell, and something that actually makes it really simple to work with CloudShell is there's also an Azure Drive available, and what this does is it gives you access to your Azure account and all your subscriptions in there, and you can kind of browse it like a file system. So this is only if you're using PowerShell, because this is using what's called a PowerShell drive. So you can see now we're in home, my home drive, my cloud drive, but we can also switch over to Azure colon. So if we switch over to here, I know that my Azure subscription starts with Azure, so I can tab. They have the same name, so that's Microsoft Azure sponsorship is the one I want to be in. So we do another dir, and what we can see is we can just browse through Azure. So we can see we have all resources, we have resource groups, we have virtual machines. So in this case, I'll go into resource groups. And if I take a look here, I can see that my resource group is actually in there. And we can also see that the CloudShell storage is also listed as a resource group here. So the advantage of this is that it's also context aware. So if you would be using any of the Azure PowerShell commandlets or PowerShell functions in the console, it will run it from the context we are in. So if you have multiple subscriptions or multiple resource groups, the moment I would deploy a resource now, it would be in the location I'm in right now. So currently I'm not in a resource group, but I am in this specific subscription. So we get to be work with it like a file system. So if I say new VM when I'm in this case my resource group, I would do new VM, then the VM would be created in this space. Has nothing to do with Terraform, but it's a cool feature. And with that, we can switch back over to here, and we can now see that the VM has indeed deployed and it is currently running. So let's verify that with Terraform. So I will run Terraform plan again. So we can see what will happen if we would actually apply this configuration again. And what we expect to see here is that there will be no changes because everything is exactly as we applied it about 5 minutes ago. So this will once again take a couple of seconds. You can see it's refreshing the state. So refreshing the state is it's checking what is in the state file and it's comparing that to what is actually running in Azure. And it says no changes, infrastructure is up to date. So this is exactly the end state we want to be in. But because I'm a good citizen and I like to clean up after myself, what I'll do is I'll run Terraform deploy. And before I do that, I'll take a look at help, because I'm very sure of myself that I want to destroy this. And we can see that if I don't want to say yes, if I'm very sure this has to go, we can use force, which is deprecated, or dash auto approve. So in this case, I will use auto approve. And if I run this, everything will be cleaned up again and will be in the state before I started giving this demo. So that is a short introduction in what you can do with Terraform on Azure and deploying and removing resources, and also some of the functionality of Azure CloudShell and how you can use it in combination with Terraform. With that, so one of the advantages of using Terraform is it's open source. There's a lot of updates, both for Terraform itself, but also for the different providers. It's very well documented, and that's actually one of the big advantages of the approved providers. They all use the same documentation format, so it doesn't matter if you're working with the Azure provider or the AWS provider or the VMware provider. HashiCorp has set very strict standards for this is the minimal amount of documentation that should be there, and that makes it very simple to actually use it over different cloud platforms, but also on premises. And well, that's one of the things that I'm particularly enthusiastic about. It's also very easy to contribute to those. So if I find a bug in the Azure RM provider, for whatever reason, there might be a typo somewhere, I can just go into the GitHub repository. I can just take that code, fork it, make the change, and then propose it back as a pull request. It allows us to manage our infrastructure as code, so it will become the single source of truth. And we've seen that because the moment I ran Terraform plan, when the machine was there, we get a notification, okay, your infrastructure is up to date. It's exactly as you want it to be. So in this case, our infrastructure was a single VM, but there's if we have a larger configuration, or if you have a collection of multiple configuration files, it can be your entire production environment. And it allows you to improve incrementally. And what it means is we can start small. So that's what we've done today. So we do a small deployment. We just try it out with a single VM. And from there on, we can work on adding in different resources. So in this case, we work with a VM, with some resource groups, storage accounts, but we could also deploy our web apps this way. We could also use different Azure resources. Anything that has a provider, we can take this, we can codify this into Terraform, and we can ensure that it's exactly in the state we want to be in. So a good example of this is your network security groups for all your Azure resources. Take that as a starting point and codify this. Ensure that there are no open RDP ports directly to the exposed to the internet, because that is a very big security hole, and that is something that you don't want for your environment, because the last thing any of us wants is to get their security compromised and have someone take over your newly deployed cloud environment. So that's what Terraform allows you to do, and I strongly believe that incremental improvements are the way to go. And with that, these are alpacas. They're very fluffy. Do you have any question?
Thanks for a great presentation. And yes, now we will start the questions and answers part. And should you wish to ask a question, please type it into the questions window now. Okay, Jaap, we have a good few questions in, so I'll get started with them. First one up, is it possible to write Terraform code which abstract cloud provider artifacts as FEVM types?
FEVM?
Yeah, F.E.VM types. That's what we have.
I'm not exactly sure what is meant by that question. So if whoever asked the question could clarify it a bit more, then I'd be happy to get back to that. But to give a more general answer, can you?
Oh, sorry. Thank you. Yeah. FE is for example. My apologies.
Okay.
Oops, I'm not up with all the lingo. I feel old now. So as, for example, VM, so I'll read the question again. Is it possible to write Terraform code which abstract cloud provider artifacts, for example, VM types?
So what you could do is you can create a VM template for You could write your own code that generates your configurations, and your configurations can be based on whatever cloud provider you have. So it won't be Terraform specific code, but there's nothing stopping you, and there are tools out there that actually exactly do this, that abstract away whatever provider you're using. You can just give some basic things like, okay, I have to have this many CPUs, I need to have so many IOPS, I need to have this much memory, and then depending on the cloud provider, it will pick a certain VM size, and it will use its own. It will use the correct providers for all the different components. So in the case of Azure, the security groups, the different interfaces, the resource groups.
Okay. Why Terraform for IAC on Azure versus ARM? When to use one or the other?
So I think this is a question not so much when to use one over the other. I believe it's good that we have multiple options and different tools. If you're already familiar with ARM and you're already actively using it, and you're not planning to work cross-platform, or you don't want to deploy on premises, assuming you don't have Azure Stack, then I would use then I would make the switch to Terraform. But if you're not going to be working cross-platform, and you're happy with the way ARM functions, keep on using ARM. I think the big benefit is that I get out of Terraform is that I'm using a lot of different environments, and because I can use a single tool to keep on deploying, I'm familiar with the format of the configuration files, so it becomes easier for me to codify my environment.
Okay.
I think one addition that I have to that is that Terraform, of course, talks to ARM in order to deploy those resources. So from a performance point of view, I think ARM is always going to be more of a first-class citizen on Azure, because that is the Azure way of deploying things. So that would be a benefit for ARM.
Okay. Can Terraform be used for software patch management like Puppet or Ansible?
You could. It depends on what kind of providers you're using, and you can also add in customized scripts to get to the end state you want to be. But I wouldn't say that is the strength of Terraform. I would still use configuration tools on top of Terraform to do the last mile. I would not go that far.
Okay.
The essence is it possible? Yes. Is it always what you want to be doing? Probably not.
Okay. Can Terraform work somehow with Azure blueprints?
I think Azure blueprints are very specific to Azure. I don't know if there's any tools that can do a conversion of an Azure blueprint into a Terraform format. So blueprints are a structured format, so it would be possible to convert it to Terraform. I don't know if anyone actually went to the trouble of making sure that this is possible.
Okay. We've experienced intermittent issues deleting resources with Terraform Azure RM. Are there any best practices you can share about deleting?
That's a good question. Whenever I run into issues when something can't be deleted, I haven't found a single reason why things sometimes fail and sometimes keep working. So unfortunately, I just take it on a case-by-case basis when it doesn't work as expected. my best practice would be to try and force it using the Azure CLI, but that goes against the whole infrastructure as code thing, because then you're going to make manual changes to your environment again. But I think the most powerful and the most direct tool in your toolbox, if anything gets stuck for whatever reason, is the Azure CLI.
Okay. Is it possible to create Azure template based on Terraform code?
I think the answer to that question is similar to the previous question about blueprints. Is it possible? Yes. Is there a tool out there? I haven't used it personally, but there might be a tool that does that for you. And if you're so inclined, you could otherwise write it yourself.
Okay. What is the best way to start learning and using this tool? Can you suggest any particular training video course, such as Udemy or maybe Pluralsight?
Yeah, Pluralsight. Unfortunately, it's May now, because last month I know Pluralsight had a free month of learning. Pluralsight is good. I think Microsoft Learn is a good resource, and I don't actually know if there's any good courses on LinkedIn Learning, but that's a resource I use as well. For me personally, I'm not so much into video courses, so the way I got started with Terraform is I just come up with a problem, and in this case, my first problem was, okay, I want to deploy this test environment, and I just started diving into the documentation, create my first configuration, fail, then go back to the Terraform documentation, and that's the way I learn. So those resources or just the documentation.
Okay. You were talking at the beginning about something to keep your VM up to date without RDP. Can you explain?
Yes. So I was trying to explain the difference between how we used to work like 10 years ago when I was a system engineer. Whenever I needed to do anything to a VM, it would mean that I would have to use RDP to actually log into a system to make those changes. And I wanted to put it against the current reality where we have infrastructure as code and where we make changes to a system by having code in a central location and pushing out the changes from there. So in this case, the central location would be your GitHub repository, or if you're running it internal, your Azure DevOps repository. This is where you make the changes and you're not actually touching the VM in any way.
Okay. Can you explain how to manage the same Terraform file for multiple environments like dev, stage, test, and production?
Yeah. So what you could do is you can have multiple configuration files in your folder. So what Terraform does when you do the plan phase, it will just load all the configuration files and merge them into a single configuration. So what you could do is you could have the base configuration, and then you have separate configuration files to specify that this is either your dev environment or your test environment, and you associate it with either an Azure subscription or a tenant or specific resource groups to indicate that. So that's how I do that.
Okay, and last question, Jaap. What is the best approach to manage credentials with Terraform scripts or in a repo?
I would use, depending on what kind of tools you have available and what kind of repos you're using. If you're working with Azure DevOps, you could use Key Vault. If you want the HashiCorp solution, you can use HashiCorp Vault for secrets management. If you use a different CI/CD tool, whatever is available there. I don't think there is a best approach. It really depends on the platform and the tools that you're already using. Vault is quite powerful though.
Well, on behalf of the ESPC community, thank you, Jaap, for taking the time today to complete this webinar. We really appreciate it.
No problem at all. Happy to be here.
And yeah, great. And if you have any further questions, you're okay for people to reach out to you. Jaap, is that okay?
Yeah, so I have my Twitter handle in the bottom left corner, so Jaap_Brasser. I had to put the underscore there because someone else already took Jaap Brasser. It's a very popular name apparently. Feel free to reach out on Twitter. Just tag me in there. My DMs are open as well, so you can always drop me a message. And always happy to help out or just talk about technology, because that is what I like to do.
Brilliant. Well, thank you, Jaap. We really appreciate it.
Thank you. Have a good day.
Thank you. Okay, everybody, this is the end of the webinar today. Please see sharepointeurope.com for further details of all upcoming webinars, or visit the Resource Center where you can see all previous episodes. Thank you again to Jaap Brasser, and thank you for joining us today. Take care and goodbye.